The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So I try to do this at least every other class so we remember the context. But class one, as you remember, was all about the economic growth theory and the economic growth context for innovation policy. And we did, growth economics and how it broke away from classical economics around developing a new theory of growth. So Solow argued that there's technological and related innovation, and we concluded that was a key direct innovation factor. So we could loosely, although inaccurately, translate that concept as saying you've got to do R&D. And then we read Romer, and Romer argued that behind that R&D system is human capital engaged in research. That's another foundational direct innovation factor. You can't build an innovation system without these two elements, arguably. So it's the R&D and the talent behind it. Those give us two direct factors. Then in class two, we talked about the indirect elements in this larger ecosystem. And government controls some, private sector controls more. But that gives us an idea of looking at innovation as a system, which Richard Nelson contributed to. And then within that system, you look at the strength of the innovation actors, and you can begin to think of your innovation organization as a third direct innovation factor. And that leads us into the whole problem of how do you cross the valley of death if you've got a disconnected model. Classes 3 and 4 were case studies on manufacturing, so we took a deep dive into a very current set of practical ongoing problems to try and think about some of those innovation organization lessons in a manufacturing context. Class 5 was explicitly about innovation organization. And we looked at David Hart's kind of analysis of the ideology behind looking at innovation in the political system, and the conservative, the associationalist, which is sort of public-private, the national security models. All those issues are still very much with us. And in that class, we also talked about Donald Stokes' work, where he critiqued the split in the U.S. innovation organizational system between front-end innovation, the R side, and the later stages. So that there's when we organized to do essentially a research model at the end of World War II under that pipeline model that Vannevar Bush gave us, we missed issues that subsequently arose in the economy and became really deep sources of problems about the connections to the follow-on implementation, back end of the innovation system stages. Class 6 was about crossing this valley of death. How do you build the bridging models that get you across from a pipeline innovation model across to the later stages? That's not easy in our system. And then we also talked about the fact that we run two parallel systems in the US. So Vernon Rutan's book, Is War Necessary for Economic Growth, introduced us into the whole defense innovation system, which is not disconnected, right? That's a pretty connected model. And the Defense Department will typically perform the research, the development. It will do the demonstration. It will do the test bed. It will move to the advanced prototypes and will often provide an initial market for emerging technologies. That's a very different organizational system, as we discussed, from what the civilian agencies are up to. Class 7 was innovation at the face-to-face level. That's our whole great groups theory. So if innovation has to do with institutions, which it certainly does, how are those institutions organized and how do they connect, and how are the handoffs between the actors? But in the end, people own innovation, not institutions. It's very face-to-face. And in the great groups classes, you remember well, we talked about some of the rule sets that tend to guide the way in which great group-based innovation operates. And again, that drives us back to this third innovation factor. What does innovation look like from an organizational point of view, from a systems point of view, from an actor's point of view, but also how does innovation look at the face-to-face level? And then in Class 8, we talked about DARPA, which is an institution that actually attempts to do both on a good day. That it'll support that connectedness of innovation institutions being connected using that defense model, but it will also attempt to build great groups. And we talked about JCR Licklider and the evolution of the IT revolution, a lot of the origins of which came out of DARPA-supported research as an example of that. So now we're going to do some more case studies in today's class, really looking at the life science innovation system. And how does that function? And we're going to take a lot of the lessons that we've been learning and try and fit them into analyzing this really important piece into this territory. All right, let me give you a quick NIH historical backdrop. Right, remember the pre-World War II and the World War II context. NIH has stood up as a Vannevar Bush basic research organization. So Franklin Roosevelt and Vannevar Bush see what happens in World War II, right? They see the development of antibiotics led by penicillin, right? And the effects are breathtaking, absolutely breathtaking. So suddenly we fight a war and you probably won't die of disease, right? You'll actually die of battlefield injuries, which has never happened before. And that immediately has an effect. It removes pneumonia from the #1 cause of death in the United States, considerably further down the list. It's very dramatic. Bush and Roosevelt see this and understand how powerful that model is. And so one of the theories in the Endless Frontier that Vannevar Bush puts out, as you remember, is that there's going to be a war against disease. And they've just seen what this model is, right? So they want to do it. Now, Truman, as you remember, vetoes the one agency, one tent National Science Foundation role, right? So he vetoes that in is it 47 or 49? And that leaves a void. So voids tend to get filled. So this little research outfit that's part of the Public Health Service, the National Institute of Health becomes the National Institutes and really starts scaling up, right? So follows a Vannevar Bush basic research model, but it evolves in this kind of gap of organizational leadership in a way, and fills that void. And then over time, disease groups tend to be very active politically, right? If you have a disease or if a loved one has a disease, you tend to be very active in the disease group. And these disease groups push their disease in Congress, and Congress keeps adding institutes and centers onto the model. When it reaches a completely unmanageable number of 27, finally Congress actually tries to restrain itself. But it creates an organizational model that's problematic. Now, another feature here is, this is a line from Tony Fauci, who's director of NIAID, quite famous. NIAID was one of the leaders in getting on all kinds of infectious diseases, including AIDS. But Tony Fauci writes in 2003, the path to product development has not been a part of NIAID's research strategy, right? In other words, that's not on the table. They're worried about their basic research results. So what did NIH and arguably the biotech model that is spawned from it, what did they get right? And they get a lot of things right. It's an amazing system. It's a remarkable story of success. So even though we're going to be critical today, it is an amazing success story. NIH trained everybody, right? Created this huge education system that put a lot of talent on the task in Romer's terms. This knowledge base helps spawn a remarkable entrepreneurial biotech startup model. And we talked about Genentech during our great groups class. That's the first, but that's a very good example of what then flourished. And you know, Boyer and Swanson were the founders. Boyer comes out of that NIH-funded system. Biotechs have been able to get venture capital support, even though they have a 10 to 15-year stand-up model, right, which is a remarkable accomplishment. No other sector is able to get venture capital money unless they're no more than a couple of years out of production. Biotechs have been able to break that and get long-term support for R&D. And the key to this has been the value of IP. So there is a working monopoly model in the biotech sector. So if you're, you know, first to patent a new drug, you are given a monopoly rent for a 20-year time period, right? Minus the time it gets you to get through clinical trials with NIH, which can be 7 years. So it's a 13-year run where you're assured of monopoly rents. And unlike the hard technology sector, it's harder to stand up, in effect, copycat fixes, right? Copycat drugs. So you really do get a significant run typically if you're first to patent, and you get ahead first through the clinical trial process. So that's been the enabler that allows this financing system to work. The other key feature is FDA's approval. So FDA gives you, in stage 1, stage 2, stage 3 clinical trials, everybody, if you're developing a cancer drug, you know exactly what your chances are on getting through from stage 1 to stage 2 and stage 2 to stage 3, right? You know, and from stage 3 to final drug approval. You know just what your chances are. So that enables venture capitalists to tee off their stages of financing to your success in the clinical trials process. There is no benchmarking system like this in any other sector in the economy. It works amazingly well. And then another big difference between life science and everything else is that if FDA approves your drug, you are guaranteed a market. In fact, our wonderful legal system is such that if a doctor fails to prescribe the medicine which is fitted to your problem, the next day, the doctor gets sued, right? So there's this huge forcing mechanism in the system. There's nothing like a certification that guarantees you a market on the next day. There's nothing like this anywhere else in our system. It's a remarkable thing. And we can start to think about how do you get analogous certification processes and benchmarking processes in place in more physical science-based technologies would be very interesting. We haven't done it, but there's a lot to be learned from this sector because of the system it's set up. Upstairs, downstairs has historically been a problem, particularly in European science, but also in US science, whereas the academic researchers have disdain for the company researchers. That has really broken up and broken apart in the life science side. So outstanding academics, think Boyer, who spend time in a biotech, that's now created as a sound career path. Boyer had to break the ground. He got a lot of flack for it at the time. But over time, it's become accepted that you can have an academic career, move to a biotech, move back to an academic career. That's okay. Obviously, there's conflict issues throughout that whole process that have to be dealt with. But that's an acceptable pathway. So the whole upstairs, downstairs relationship between the academy and commercial development has really been broken up. So that's another thing that this sector got right. NIH also has a huge amount of money. It's by far the largest R&D agency. It's got over $30 billion a year. Nobody is close. NSF by comparison is $7 billion a year. The Department of Energy Office of Science is $5 billion. DARPA is $3 billion, right? So this is an order of magnitude almost different from other R&D agencies. So the political constituencies, including the disease groups, have built a very powerful political base for sustained funding in this sector. Now, that's the good news. Here's the problem. we're going to talk about the innovation train wreck that lies ahead here. So the economic model for biotechs and pharmas really requires blockbuster markets. It's a huge problem. So in other words, third world diseases, infectious diseases, small population diseases, it doesn't make sense to pursue those. To get a drug through the FDA clinical process, the development time before, during, and during the clinical trial approval process itself, that's around a $1.4 billion or more proposition. So unless you're selling into a major market, it doesn't make any sense to develop the remedy. So there is a statistic that some cite, which is that 80% of our R&D money in life science is spent on 10% of the diseases. That's a problem. I don't think the number is that bad. I think that's exaggerated. But we've got a problem here because of this blockbuster drug model. Only if you're developing a drug that sells into a major market opportunity is it going to get into the market. So what does that leave behind? In addition to the things I've mentioned, the precision medicine or personalized drug model gets left behind. So in other words, if each one of you is going to have their own remedy variant that's particularly adapted to your genetic structure or metabolism or whatever, what are we going to do? Run a $1.4 billion clinical trial process for you? It's not going to work, right? So how do we deal with this, right? This is a huge looming train wreck problem in the system because that's where it's going, right? This is the benefits of being able to use big data and analytics is to develop personalized medicine, but if there's not an economic model to get it there, it won't happen. The litigation threat makes drug companies risk averse, so we leave a lot of promising stuff on the table because of that threat. Often a drug will cure, let's say, 20, 30, maybe 40% of a disease group's problem. But if it kills some people, it will never go to market, right? Because we don't understand the precision medicine, the personalized medicine implications of these things. And until we do, we're just leaving a lot of stuff on the shelf that has potential value because Americans, for good reason, have very low tolerance for risk from drugs. The healthcare spending of the overall system by 2025 may account for 9% of GDP or more. And, we'll talk about this in a minute, but we can't afford a healthcare bill of those dimensions and still have other things going on in the society and the economy and the government. This is what we spend money on in the federal government. This is what we think of as government, right? So that's like the national parks and federal research, transportation, highways, that's defense. So that's actually about 16%, and that's now about maybe a little below 20%. That's Social Security, that's Medicaid, Medicare, and S-CHIP, right? The big healthcare-oriented entitlement programs. That's other safety net programs, 9%, and then we have interest on the debt, which is actually now over 9%. So as you can see, the federal government is mostly, we're talking 60%, plus interest in the debt, a check writing kind of organization, right? And that's what we think of as government, and that's what we think of as the domestic side of the government. So these are pretty small pieces. Rashid?
What year is this for?
This is probably about 4 years old now, but the numbers are slightly even more problematic than these. So again, this category is now 16%, so the numbers are probably off by a couple of percent. But it's a problem, right? And as we'll see in a second, these are components of federal spending. So that's health, and that blue line is everything else. So you can see where taxpayer dollars are going. This kind of demonstrates that Social Security is not the real problem. It's really the healthcare costs related to Medicare and Medicaid that are the problem. This shows historic levels of taxation. Remember, the United States was founded around a tax revolt, so we're not going to have European-style levels of taxation in the United States. It's just not going to happen. And we start to run into real political trouble once you get a little bit above, say, the 20% kind of level of taxation of GDP as a percentage of GDP, right? So, you know, we're headed way up against that threshold, which in turn means, largely because of the demographics and the healthcare spending, which means that broken down this way, the percentage of GDP we spend on what we consider most of government, just not going to be affordable, given what the acceptable levels, around 19%, 18%, the acceptable tax range in our political system. So, Max? Expenditures by the federal government, what they're spending in a given year, what they were actually outlaying to meet their costs, to meet their obligations. So these are some of the problems that lie ahead. We've got a real fiscal train wreck because of the cost of this healthcare system, driven by the demographics. You know, my generation attempting to make you spend all of your money on me, right? That's essentially what's going on. It's a massive intergenerational transfer of wealth. And you guys need to wake up to that because it foregoes opportunities that you have. And at the heart of this is a really serious problem with healthcare expenditures. So let's now get back into our main themes. This was a classic 2003 report that what is now called the Academy of Medicine, used to be called the National Institute of Medicine. It's part of the national academies. They did on evaluating NIH. And it was a pretty startling criticism. And they, looked hard at this NIH system and really began to identify some of the problems. Interestingly, this report drove some interesting congressional reform attempts. Let me see if I can summarize a few key points here. And Chloe, did you have this one?
I don't think so. No, the first one.
You've got it, Martine? Okay.
Yeah,
all right. So, as I said, NIH is more like a feudal barony, right? Always has a famous director, but they don't have that much control over these institutes and centers. There is no centralized budgeting, right? And the institutes and centers battle to protect their percentage share of NIH's total budget. So Harold Varmus, a famous former director of NIH, who later came back in the Obama administration as head of the National Cancer Institute, he said in 2001, NIH would be more efficient and more manageable if a far smaller number of larger institutes existed organized around broad science areas. Less institutes organized around science areas is his twin points here. And there's a lot to be said for that case. Instead, as we discussed, the institutes got set up essentially at the behest of disease groups to solve their disease problem. It turns out there isn't a separate pathway for each disease. It turns out there's a lot of common pathways across a lot of diseases. And we don't have a very good mechanism in NIH for getting groups of institutes to collaborate on a cross-cutting set of problems. It's a fundamental organizational issue. Now, there is another side to this argument, which is you've got a lot of institutes with a lot of freedom to do a lot of stuff, right? Maybe a disaggregated model is not all bad, right? There's certainly a case to be made for that. But overall, there's a challenge here. And NIH's budget doubled from 1998 to 2003. So there was a big growth. There was a federal surplus in its budget during the IT revolution, which was generating huge amounts of tax revenue. And two US senators saw this emerging surplus. They were on the appropriations subcommittee that handled NIH, and they went to the Senate floor one day and took a noticeable part of that surplus and gave it to NIH. It was a fascinating political development, very shrewd. Arlen Specter of Pennsylvania and Tom Harkin of Iowa were chairman and ranking on the appropriations subcommittee, and they created the doubling. It's a remarkable story. They were able to do it because there was so much excitement at that time over the genomics revolution. So we talked about Venter and the NIH dueling battle, Collins, over who's going to get to the genome first. There was creating huge excitement. There was a sense that this medical research could lead to all kinds of new fundamental understandings. Everybody was excited about the idea, and that enabled those two senators to double NIH. No other agency has ever been able to do anything like this, right? The rest kind of are stagnating. But the demographics are changing. The patterns of illness are changing. We have a threat of biothreats. Is NIH too fragmented to cope with all these challenges? Can it respond quickly enough? These are all issues that the report raises. It wants to avoid proliferation of new agencies, and in fact, Congress did that as part of its reform legislation. You can't have a new institute at NIH unless you close down another one. The Institute of Medicine and now the Academy of Medicine urged in this report that NIH focus on its capabilities, and it needed to do so because it concluded that NIH is not only imperfect, but nobody would have ever designed NIH this way at the outset. And in fact, Elias Zerhouni once told me in a meeting, and others, if only we had thought through the organizational model before we doubled, right? So we doubled first, and then there was a mad scramble to grab the money from the existing institutes. If only they had thought about the organizational model up front. So Zerhouni led a great effort to try and get cross-cutting research efforts going across the institute. So he created what he called the roadmap, but essentially, and Congress later institutionalized it as the Common Fund. Take a little bit of money from each institute, create a common fund under the control of the director, who can then allocate it to the highest cross-cutting priorities. So that was a significant reform, but it's still a very modest amount of money. NIH needs to pursue an ability to go after high-risk, high-return projects. That reaches a certain stage, and we'll talk about this more later, but peer review is not good at taking risk. If there's a certain level of competition, if the award rate gets higher than about 1 out of 3, your ability to identify breakthrough opportunities that are feasible gets harder. So it tends to default to, when there's a lot of competition for an award, the one that the peer community is most confident will yield results, albeit they be incremental results. Why take risk on high flyers when you've got to get the basics done and so many people are fighting for the money? So this is a huge problem at NIH. How does it take the necessary risks that need to be taken in innovation? So since then, NIH has been working on creating categories of higher risk projects that have a separate kind of review process than normal projects. So there are positive NIH capabilities. We talked about how decentralized can be an advantage. We talked about many setting R&D priorities is not necessarily, you get a lot of safety nets here. There are benefits to investigator initiative grants, right? You don't want to just have large scale projects. You want bottom-up opportunities. The issue for NIH, though, is historically it's been totally dominated by bottom-up and has a modest number of kind of cross-cutting projects. You know, peer review in some ways is like Winston Churchill's definition of democracy, worse than every other system, the worst possible system except for all the others, right? So peer review remains competitive, and that's a very important feature to build in. So IOM recommended much more centralized management, giving more authority to the director of NIH, getting the director to engage in strategic planning across the institute so they got on to cross-cutting plans. doing cross-cutting budgets. So this idea of take 10% of the budget and fund the strategic plans. Actually, Congress worked on implementing that through the Common Fund. Strengthening the, control of the director over these cross-agency initiatives was key. They also recommended creating a DARPA within NIH to go after the high-risk projects, the high-risk, high-reward projects. They wanted improvements in NIH's intramural programs. So NIH is also a major research entity itself. It's not just funding universities. That historically has tended to be somewhat weaker than the university research, which is much more competition-based rather than kind of entitlement funding-based. They wanted to strengthen that. There's a desperate need for standardization of data and information systems across these different institutes because a lot of these diseases are related and you can learn, they can learn from each other and you can't do cross-cutting data analytics. So there's a series of kind of reform steps here. As going back to some earlier points we've made in the class, NIH is not a connected organization, right? It's an early stage basic research organization. It's not connected to the follow-on stages. Now, it has managed to create a model through biotechs that are venture funded that is able to get across the valley of death if you've got a blockbuster drug, right? That's pretty creative, right? Other agencies haven't come up with that. So, we need to, and it's not as if NIH was sitting around figuring it out, but in effect it occurred and the training of the talent helped it occur through people like Boyer and Swanson. Martine?
When we define blockbuster drugs, is it one that makes a lot of money or one that impacts a disease that a lot of people have?
One that makes a lot of money.
Okay.
Right. I mean, in theory, it won't get through FDA unless it actually solves a problem, right? NIH is primarily small grant research and lacks the capability to set up initiatives across the stovepipes, as we've talked about before. It tends to be fairly slow moving. There's a risk in peer review of avoiding high risk, high payoff approaches. There's limited connections to industry. In other words, that translational research effect is hard to do at NIH, although Collins, who's the current director of NIH, has worked on creating a special translational medicine institute designed at that problem. So NIH has been taking steps on these. I think that's a pretty good, I'll give you one more example. Nanotechnology. The earliest beneficiary of nanotechnology was probably the semiconductor sector, but the life science sector, the health research sector was very close. Huge potential opportunity spaces in understanding things at the nanoscale here. Because of the disaggregated structure of NIH, for many, many years after the nanotechnology initiative was created, NIH, by far the largest research organization, was only spending a fraction of what the National Science Foundation was spending on nanotechnology. Even though the gains for the health research system were, and clearly are, phenomenal. So that's an example of a problem in being able to attack, a whole new approach to disease across this very disaggregated model. So, I mean, that's the IOM report of 2003. We've learned some lessons from this. We've tried to make some changes, and Congress has actually provided a fair amount of leadership on that in creating the Common Fund and capping the number of institutes. Martine, you want to take us through some questions on this?
Do you actually want to do the Cook-Deegan one? Because that way I can just integrate them, and it might be easier.
All right, we can do Deegan and do it together. And we don't need to spend a lot of time on this because last week's class was on DARPA, so I'm not going to recap this. Robert Cook-Deegan was deputy when Watson was heading the genome project at NIH, so he knows NIH from the inside. He later went on to head Duke's Genome Institute, so he's an outstanding researcher. And now he is teaching science and technology policy at the Washington branch of Arizona State. So he's gone over to the dark side of science policy, where people like me inhabit the world. But he's got real talents, unlike me, actually on the technology side. And he wrote this piece back in 1996, fairly fresh off his own NIH experience. Does NIH need a DARPA? And I can't tell you how controversial this was. NIH has always viewed itself as better than everybody else. And the fact that one of their own, the deputy director of their genome project, was telling them that there was a better model out there that they ought to at least consider adopting for part of their operations, certainly not for all, was a powerful message. And we know the DARPA story, so I'm not going to recap that. Robert Cook-Deegan underscores that the DARPA model suggests that peer review is not the only way of organizing research. DARPA has far lower transaction costs than NIH does, a lot lower review costs per science direction. He introduces this issue of how conservative peer review gets when it gets to an award rate that's, much worse than about 1 out of 3 grants, applications per grants awarded. NIH has got a very limited ability to do the kind of grand challenge model, to kind of pursue that challenge model. It's got limited ability to take high risks and get high rewards. It's got a lower risk acceptance capability. Those are DARPA things that NIH should have, not all of NIH, but certainly some part of it might adopt, he argues. He cites a lot of examples. NIH, the Human Genome Initiative actually originated in the Department of Energy because the Department of Energy understood supercomputers. So for the first 5 years of the Genome Project, it was carried by, the supercomputer gurus at DOE because they understood what the potential of supercomputing was going to be in figuring out the genetic structure. NIH only picked it up when it saw the promise of the model. NIH had terrible trouble coping with the advances made by Leroy Hood, and we'll talk later about Venter, and kind of how do you adapt and incorporate a computational model in medical research. They're locked into a biology-only drug development model pretty much, right? It's hard for them to do other territories, as we'll talk about when we get to the convergence report. So the lessons from DARPA for handling multidisciplinary approaches and bringing in a group of talent around a problem that comes from different fields, there's lessons here for NIH. That's the heart of Robert Cook-Deegan's recommendations. And Martine, it's yours.
Okay, cool. So I think you did a good analysis of the papers, so I won't really summarize too much more. I think we can just go straight into discussion. And so I think a good first question would be, how do we know that there's a lot of costs in the healthcare industry, and the system and the structure they have isn't perfect. And so how do we create a system so that these problems that need to get solved but don't have economic incentive because they're not blockbusters, how do you combine NIH with maybe some DARPA-like abilities in industry? And if anybody's specialty is like high research, it'd be interesting to get your insight first.
What do you mean by high research?
Well, you're focusing on like an academic career in a lab, in a national lab. Or, you know more about that than I would.
Where's Lily when you need her?
Yes, you got it.
Yeah, I think you probably, as Cook-Deegan kind of laid it out, you just really struggle in this peer review process if you have an idea for maybe not a blockbuster drug, but like a new approach to a system that hasn't really been tried out yet. And so that's why you see like Hood and Venter have this huge problem. And I think it really is just kind of allocating a part of the NIH, budget that they get to sort of this DARPA-like high impact, maybe high risk research, and then kind of moving from there. But I'm not sure, because it kind of takes so long to develop these things. So like a 3 to 5 year, and then you have to sort of figure out clinical trials and things like that. Like, would the time scale need to be adjusted to account for kind of doing the research and then moving into clinical trials to be able to like actually support kind of these high risk initiatives and a lot of these I feel like will be building on research that doesn't really exist or isn't really there yet. So will they need more time to sort of stand up in the field?
Yeah, I think there's probably two main ways that maybe some of the later readings touch on more, but definitely kind of incentives on the FDA's part to extend and make that process a little bit more profitable than, say, if it's on like an orphan drug where you have a very small kind of market that could be addressed when the drug comes out by kind of increasing the patent life. So they have like extended patent provisions for those kind of drugs. That definitely helps kind of make it more profitable. And also a lot of the later papers talk about this, but they have a lot of flexibility in the way they can price their drugs. So I think that kind of helps a lot, because if they can charge like a lot of money for like a dose of a very niche drug, that kind of compensates for the fact that you're not giving it to as many people.
Mm-hmm. And I guess my concern with that last point is, what about a Martin Shkreli situation?
Yeah. I mean, yeah, obviously that's going to come up, because all these companies will want to, you know, recoup their costs, because they're spending millions and billions of dollars on these drugs to develop them. And there's like kind of an argument for both ways, that, oh, it's kind of justified, but I mean, obviously bad for society, right? So there's a balance there.
It also, you could make a very similar argument for any other drug in like one of these blockbuster drugs, as we say, because, well, you could still charge an exorbitant price for them, you can get tons of money for them, and then you're back to square one, where, okay, let's just keep funding the drugs that we've been doing, because don't fix what isn't broken, right? So I'm not sure how it would incentivize people to focus on these smaller drugs. Now, one way you could do it, maybe, I don't know, tax incentives or something, maybe force insurance companies to foot the bill a bit more, but I don't really know the details of how that would work.
Yeah, this is one of the great societal dilemmas that we've got in healthcare at the moment. You want to create enormous incentives for researchers and the biotech companies they may create to go after these big problems. You really want to incentivize that process. So if you start to de-incentivize it, you're going to have less remedies on the table. On the other hand, you know, you've got serious cost problems for some portion of the population that's not going to be able to cope with the cost structure. And you're going to have real reluctance on the part of government agencies to subscribe for a huge cost burden that only helps a relatively small number of people. So this is a dilemma that is now upon us big time, that we have not sorted through in an intelligent way. And there's, you know, constant reviling of drug and biotech companies, but on the other hand, they're the ones that created these opportunities for us. So it's a very contradictory. The politics doesn't seem to recognize the importance of the innovation system, and yet we don't have the right balance between the two.
Yeah, I was just what are your concerns on the policy side, or whatever?
Oh, I actually was going to say that I think the dimension that's also missing is something we touched on last week, which is the ethical components. I think there's really a rising bioethics community surrounding issues of utilitarianism versus issues of human suffering, right? Like, do we seek to address the person who is suffering the most, or the number of people who are suffering? And that is a really difficult, I think, ethical question that has yet to be addressed on a national level. And I think it's easier, I guess I think about it in terms of heuristics, right? Like shortcuts for decision making. If we understand what our values are nationally, we can understand where to begin to allocate money. And if we sort out our national values in terms of the life sciences and what we think are our national priorities, perhaps maybe through a referendum-like system, I think it would actually be a much more efficient and accountable way for the government to make funding priority decisions, rather than for life sciences organizations and the NIH to sort of make those decisions for themselves or for the citizens, because ultimately this is an issue at the human level, and that implies an understanding of bioethical considerations.
Yeah, I think that tends to run into a problem, however, with kind of root attitudes of the American population. I mean, I would say that a lot of the American population believes that we should be allowed to live forever, right? Because, you know, we're Americans, so, you know, we should be eternal, right? I'm exaggerating a bit here, but there's a lot of thinking along those lines and a lot of assumptions that any cost, whatever it is justified in terms of, you know, the outcome for my health. So these are really tough decisions, and the life science system is now right up against this, and the whole innovation model is right up against these. So these are important considerations.
Yeah, just my kind of concern with the proposal, as far as putting it in the hands of like American people, is kind of what questions are appropriate for like lay people to be answering versus the ones that experts should. So like a lot of people would debate that like the Brexit question wasn't really something that the average person could understand well enough to like make an informed decision. And so I guess if you're asking strictly like what are your ethical beliefs, like vote on that, I guess that's something that people could vote on. But if you're given like options of like should we fund something that will save like X number of people at this cost, like kind of weighing that information is more difficult than I think the average person is willing to put the time in to understand. So I do think that to some extent like NIH and these kind of organizations need to make the decisions on what our national priorities are, but ideally with some input from us.
I want to push you back to the kind of issue that's before us in this class, which is the innovation organization model that we've got here. So we're looking at an innovation organization that evolved in a very historical set of ways, where the problems when it was in the foundation level turned out to be, the scientific problems turned out to be different than the way we see them now, right? We tend to see that there are a lot of cross-cutting scientific approaches that cut across many disease pathways that may be critical for those diseases. Whereas back then, we saw, oh, there will be one remedy for each disease, right? A much earlier stage scientific notion of disease. And we're caught up in that model. And how do we bring change here, right? We're up against a legacy sector problem, as we'll talk in a little bit. How do we bring change into that legacy sector from an organizational point of view?
I have sort of, not an answer, but like a non-answer. And going back to the attack on peer review, as it were, I think that's a very odd place to start in terms of something to get rid of. I think there were definitely a lot of reasonable arguments presented in favor of adopting something like a DARPA model. But, and then going back to your ethics, you raised the point of bioethics considerations. It seems to me that peer review in the system of peer review, the values of peer review are so deeply ingrained in the biopharmaceutical, well, more on the biological and medical research community. It seems like it's very much part of their values, and it would be very odd to me to see those separated out, because I can recognize all of the detriments of the peer review system and how it can favor incremental, non-important research over big innovations and risk takers, but it still seems like if you remove that barrier, then you might have a flood of ethical problems that would just start cropping up.
Right, and look, I mean, the DARPA model does not work in all circumstances, right? In other words, the DARPA model is very much a top-down model. A bunch of elite program managers are looking at things they want out of the end of the innovation pipeline and designing projects to get there. And we can certainly see why there's room for this model, for that kind of projects-based, challenge-based model. NIH offers the other side of the coin. Researchers propose funding, and they get funded based upon the interest and quality of what they're proposing. That's very much a bottom-up model. In other words, a lot of people can see a lot of stuff from the bottom level that a top-down model can't necessarily see. So, Chloe, you're right. It's not that you want to replace NIH with DARPA, right? I think what Robert Cook-Deegan would say is maybe there's room within a large NIH entity for a DARPA-like piece. Just as there is in the defense innovation system, DARPA is only one element of a much larger defense research portfolio, but it does provide some interesting capability. And your point about, and peer review does have advantages from that bottom-up perspective that a top-down, strong program manager perspective will not necessarily be able to capture.
So from a business perspective, the thing I'm wondering about is because there's this trend right now called social bonds, which what they do is like they look at the parts of society that are really wasting a lot of money, and then they create businesses to solve them, and then they give a return. Because like you could define, that's why I asked about the blockbuster drug, because you could define a blockbuster drug as also a drug that reduces a ton of costs for the government, and the business model is the government saying, oh, we're spending $100 million here, you solve this problem, we're going to send some of that portion of the money to you. And that's a good way to cut the fat, kind of, because if the major problem is we're going to use all our budget to solve these diseases, there's probably like a disease that's like 80% or like a huge proportion, because it's not going to be a linear relationship with the cost. My other concern too was when you said that they doubled the budget. This happens a lot in software, so it's hard and not intuitive to understand, but it's like, say we were going to have the lunch, right? And I say our budget is $100,000. Then like I have to justify.
That would be quite a lunch.
Yeah. Well, yeah, that's the thing, because like by that point we're not just eating, right? It's like, okay, now we have to justify the $100,000, and then we could justify it and do like a cool example is like right now there's a startup in Silicon Valley that spent like $120 million to develop a juicer, and so that you could only juice with a machine, and then like a reporter was like, I call your bluff, and they like squeezed it with their hands and they did it. So like my concern is like when you have too much money, you tend to have to justify things, and you come with this weird logic tree, and you don't really fundamentally solve the problem. In code, like if there's a piece of code that one coder can do and you put 5 people, it actually complicates it, makes it way harder. And now you have people infighting. So that was my big concern with that too.
I think, and Martine may be trying to get at it, like this kind of group theory doesn't really exist or kind of breaks down in NIH, because it's really hard to get these cross-cutting technologies and kind of encourage that collaboration. And I think like what I really want to see out of like the DARPA that they pull is not so much get rid of the peer review, but like start, because DARPA has the ability to kind of pull these great groups together and just like call on a lot of different folks from a lot of different areas, and then like direct them towards a specific kind of research problem. And I think where NIH struggles is like, yeah, they might have a call to say we want to get rid of, I don't know, cancer or like heart disease, but there are a lot of different folks kind of working on it, and not a lot of them, I would say, probably work together in tandem to really figure out and solve maybe one aspect of that problem for, maybe 10 years, and then they focus on, a different aspect of how heart disease could work in a different lab. And I think NIH really struggles in kind of pulling together these cross-cutting technologies because there's no one kind of pulling them together. And they kind of just leave it up to the discretion of the researchers and scientists and maybe the pharmaceutical companies to come up with incremental advances rather than like really calling for, not only like calling for big calls or like big research projects, but also like funding and making it possible for great groups to work on these research projects.
Next. Martine, you want to give us some closing thoughts on these two pieces? Oh, I'm sorry, Max, did you?
I actually had a quick question. So, given that this was published 21 years ago, give or take, I'm curious.
Robert Cook-Deegan's piece, you mean?
Yeah. Did NIH ever attempt anything like this? Because, we've had some significant time period. Did they at least look at it, or did they decide no?
And also, how much criticism did he get for publishing it?
It was a threatening piece to the NIH and life science community, frankly, arguing that there may be an additional model that you all need to consider. So it was not received with open arms. Now, in fact, the current NIH director, Collins, has early on in his tenure as director latched on to the problem that NIH has got in doing translational work. In other words, moving a technology from the basic stage into follow-on sectors and doing the handoff to the private sectors. So Collins began to focus on that problem. And there was discussion at that time of doing something like a DARPA. So his effort to create NCATs to do translational medicine, the director that he hired to head that new institute, and he had to close another one to do it, right? Actually really began thinking seriously about should there be kind of DARPA-like elements in this new NCATS entity. Chris Austin, who was that director, very talented and very interesting person, however, just didn't have the resources to set up a whole new kind of entity within his NCATS piece. But so it's an idea that continues to kind of kick around here and there, and would be, frankly, I would view it as an interesting additional feature for NIH to do some things that it can't really do without this kind of organizational model. So I think there's organizational lessons here that we can take from the issues we've been reviewing and apply it to a long-established research entity to kind of create new things in the model. How about some closing thoughts, Martine?
The closing thoughts is that we discussed the NIH model and how it does work for what they're doing, but also how there's a lot of blind spots in areas that aren't being touched into and trying to solve. And then we discussed DARPA, which might be a good way of solving it, but it seems like it won't fit in well with NIH. But there is a structural dissonance, I would say, in terms of this form factor does not work for these kinds of problems. And it might also be the group kind of groupthink in the area that affects their ability to solve these kinds of problems. So it might be better for there to be like a DARPA NIH, but not at NIH or nearby, because it might be too difficult. And also, how do you create natural incentives for the researchers? Because it seems like they do these kind of leapfrogging research initiatives because it's a lot simpler and they have a lot to lose if they do fail. And so how do you create this kind of comfort zone for researchers so that even if they do fail, they get some kind of reward? And how do they get recognition for that sacrifice of their, what you call like academic career? Okay.
Right. I mean, that's another issue too, which is having multiple PIs, on the problem is complicated in an R01 award process that focuses on the single PI. Let me go on to the next couple of readings, and we'll do them as a pair. So the Infectious Disease Society of America has this report called Bad Bugs, No Drugs, which essentially summarizes the whole problem. And then the Food and Drug Administration has a paper on innovation or stagnation, right, which focuses on some of the problems they face. So let's do those. And Chloe, do you have those, or Martine, do you have one of those?
You have four. I know I have. Which one?
Bad Bugs, No Drugs, the Infectious Disease Society.
Innovation and or stagnation.
I can do this one.
Okay.
I'm prepared for it, yeah.
All right. Well, Chloe, which one do you have? You have the FDA one?
FDA.
Innovation, stagnation. All right, fine. Okay. I mean, the title gives this story away. And this is the Infectious Disease Society. And, they note that resistance to bacteria, I think as everybody in this classroom knows, is very much on the rise. And again, this report was written a few years ago. 2 million people in U.S. hospitals are going to get bacterial infections in the hospital, and 90,000 of them are going to die. That is a staggering number, right? We lose 30,000 people a year in automobile accidents. We're losing 3 times that many in hospitals. So talk about tolerance for risk, right? Americans haven't fully woken up to this. So hospitals are increasingly a dangerous place to be. And only 2 classes of antibiotics have been developed at the time this was written in the previous 30 years, and one of those is already facing resistance in this kind of endless cycle of build up of resistance that bacterial sources go through. And it's, by the late 1960s, 80% of staph bacteria were penicillin resistant. And in pneumonia, 40% of the infections were resistant to one drug and 15% to the next 3, right? So this is a serious growing problem. Yet because of the blockbuster drug model, there's no incentive for drug companies or biotechs to go after these antibiotics because they cure the problem, right? So you take the antibiotic for 2 weeks and the problem is solved. What you want under the blockbuster drug model is something that I'm going to have to take for the rest of my life for $100,000 a year, right? You don't really want to cure it. You want to create incremental advances that manage the problem. Whereas the antibiotic actually cures the problem. So there's very little incentive, since there's no economic return here model that works, there's very little incentive to go after these antibiotic problems. They work too well, too fast. So it's a very weak return on investment. And successful antibiotics are just too successful to justify the investment cost. So everybody is aware of this. Elias Zerhouni, who preceded Francis Collins as head of NIH, had this roadmap model, and this was certainly on that list of cross-cutting issues that need to be dealt with. But how do you get around the kind of model here, the economic problematic blockbuster drug model here? So, I mean, there have been a variety of ideas advanced. There was BioShield legislation to deal with biothreats, but it could also bear on infectious diseases. The idea there was, for biothreat, why would anybody develop a biothreat remedy? Because the drug would only be sold if there was a completely unpredictable, terrible national disaster. So are you going to take all the risks and go through the $1.4 billion clinical trial process to develop a remedy for something that may well never be used, right? Similar kind of problem for antibiotic drugs. So the Infectious Disease Society said, wait a minute, the same model that would deal with biothreats, which is that the government would agree to buy a certain number of dosages, a certain volume of the remedy at a set price if you develop the remedy. So the risk on the part of the government is actually pretty low. It only has to buy something if you solve the problem. But then, of course, that's what biotechs do anyway. That's the model, economic model they work off of. So could the government intervene in this sector and, in effect, really change around the risk-reward model? So ideas like this kind of come to bear here. We certainly haven't solved this problem. It remains very much with us, but it illustrates what the issues are. This other report from the FDA, Innovation, Stagnation, Challenge, and Opportunity on the Critical Path to New Medical Products. And both these reports, by the way, have been updated. I put the originals in, which are fairly hard-hitting, but they've been updated since then by these organizations, so you can get later versions. FDA does not have its own substantial research arm. NIH does the medical research. Yet, we're not doing research on how to get a better, more reliable, and certainly speedier evaluation and approval process for FDA, right? We don't have that. There's nobody on that problem. NIH does not view that as their problem. They view their problem as developing new drugs, right? New therapies, not figuring out a safety approval set of problems. So nobody's really on that problem except for FDA's own fairly modest research budget. So the picture that this report portrays is ongoing breakthrough scientific discoveries that get nailed because the drug approval process isn't receiving new science and new technology advances that would enable it to keep up with these breakthroughs. And we mentioned this earlier, but the most serious one that's ahead is in precision medicine and personalized medicine. In other words, developing a therapy or a remedy that's uniquely appropriate for you as opposed to me, right? A personalized medicine approach. How are we going to do the approval process for that? How is FDA going to manage that, right? So it's, it is a dilemma here in the system. And again, it's an innovation organization problem. We've got an innovation organization that's focused on one set of the problems, and they've got the resources to do the R&D on it. And yet we've got a parallel big problem that's jeopardizing the other system, and we don't have the organizational capability of acting on it, right? So then this is yet another innovation organizational problem. And when you think about these things as systems, you begin to identify what the gaps are, and here is one. That's probably enough on this topic. So why don't we go right into some Q&A on this. Martine, you want to lead us on bad bugs, no drugs?
Yeah. So I guess the main theme of this is there a way of using policy or subsidies to incentivize the private sector to take on this problem, or is the private sector even the right entity to handle this problem? Any thoughts?
I feel like Bill's suggestion of having government guarantee to pay for a certain amount of dosages seems like a pretty good fix for it. If you leave the free market alone, these companies they currently don't have incentives, so I don't think that's really an option.
A professor of mine, an economics professor at Wellesley Coyle, is very supportive of patent extensions, which is something that was cited in the report, and she felt like, at least in my understanding, that would very much motivate bio and pharma companies to do research, primarily because they're concerned that their patents are going to run out in the life cycle of the innovation process.
Yeah, and explain how that would work, Steph.
Oh man, I don't know that I could do it justice.
Just briefly, give us a snapshot. Or Chris.
So I think my understanding of the patent extension process is that, especially for like orphan drugs, where it's like under like 10,000 people or something like that, so smaller market size, or it's like targeting children, like adolescents, you get patent extensions, and that could be like 3 to 5 years extra, which is pretty significant in terms of like drug companies. And yeah, I think those are the main ones. And there's also like breakthrough therapy designations, and those kind of not only help speed up the approval process, which is really valuable for these companies that really want to push through these drugs really quickly and kind of get it to market. And then they also extend a little bit in certain cases. So there's like a lot of different small ways the FDA is trying to give more incentive, which is nice to see, I think. I think it's a good policy.
And to add a lower order analysis from my microeconomics seminar, I think the way that she explained it was essentially, and all of you may know this, I did not know this until like 2 years ago, so maybe this is new to someone, is that researchers, from the time that they apply for a patent, they have, 15, 17 years, something like that, to commercialization where their patent is protected?
I was 20.
20?
It changed.
Yeah, the patent term is now 20.
Now 20, okay. So like, it used to be
From 17.
17, and now it is 20. And so the way that she explained it to us is that because a lot of the research and development process could take 20 years by the time that they get a drug to market, they may have already lost the patent, so it no longer becomes economically advantageous for the company to pursue commercialization of a particular therapy, and thus what Chris was saying. So that's just sort of the small connections.
Separate concerns, sort of from like a scientific or like biological perspective. So I wonder if is it that these drugs aren't super effective, or like antibiotics aren't the best mechanism to get rid of these bacteria in the way that we traditionally think about them? To say that one, is the way that we think about bacteria like existing, is that the actual most effective means, or is that actually how they work, or do we not understand the pathways of like how they're actually becoming more resistant to these technologies? So I question, is there just kind of like a groupthink in the way that we think about antibiotics and bacterial theory in biology or in medicine, that sort of just like we're just kind of following along the same path. So I would love to talk to a bacteriologist. And then two, is this problem one that we will ever solve, or will it just get exponentially worse? Because I can imagine even if we come up with like faster and faster mechanisms to get out these antibiotics and reach more people, will these bacteria just kind of keep growing and get faster and more resistant, and like we'll always have this problem? And then thirdly, does that mean that we should have sort of like an established or kind of an entity within the FDA that like just deals with antibiotics if they deem it as a serious enough problem and it's going to be persistent?
So you're both bio, right?
I'm Arrow.
Yeah, I can try to.
Well, the question I was gonna ask is like you can talk about this theoretically, but I was gonna ask. So if you had to start a company, right, and you're like relatively young in your career, and this might be a career ender in terms of like if there's no success, what incentives would incentivize you to start a company to solve this problem?
Like.
Or an organization,
Antibacterial.
to work on this exactly.
Presuming you have the equipment and
Yeah.
resources.
So antibiotics are pretty difficult. First of all, because they're becoming too effective for their own good. Like, I think it was Pfizer, one of the big companies, produced a very famous kind of antibiotic drug, and now it's just like so effective that they've kind of become a victim of their own success. And also, it's also really hard to pass antibiotic drugs through clinical trials, like disproportionately so compared to other diseases. So that's also kind of like a barrier to entry. I think honestly, if I were to want to, get into this field, you have to come up with a new approach, like something better than is being done right now. Because antibiotics is just, it's a very broad field. There's like so many different strains, and if they like mutate a bit, your drug can be already rendered ineffective. So it's just one of those fields that is always evolving. So not only do you have to have very strong basic science to keep up with like what's happening with these bacteria, how are they like mutating, and how are they kind of evolving, and then you have to come up with drugs to help target them. So it's like a very twofold problem that you need to kind of simultaneously target. And then obviously they're evolving so rapidly that you have to kind of pivot very quickly. So I think it's one of those fast-changing fields that is kind of hard to target, but definitely important. I'm not really sure what mechanisms they have in place, or like organization-wise, to kind of target this specifically, but I think definitely should be a focus.
You talked about what's it called like your pipeline for like getting approved. What if they could speed that up like very quickly so it's a priority to get that?
Speeding it up would help, but also it's just like hard to kind of produce a good clinical trial for these drugs. So I think that's like also a fundamental problem. It's just like psychiatric drugs; those are very notoriously hard to prove because like placebo effect is really a big problem.
So that leads us right into our next reading, which is this FDA problem and the fact that we haven't put resources on the drug approval process. So Chloe, it's yours.
So if we're starting off with tackling that problem of how do we sort of reform and revamp the way in which we evaluate these products, one question for you guys would be, so the reading mentioned that one of the things you could attribute this mismatch to was a mismatch between the levels of how far both research in basic science and applied science, like where they're both at. They're very mismatched in terms of one of them is just shot ahead and the other can't even keep up. So what are your thoughts on how or if an agency such as the FDA should be responsible for ensuring that the development of these sciences are evenly matched? For example, should the agency bottleneck the funding for basic sciences until applied sciences can catch up, or should they aggressively stimulate opportunities on the other side? Or?
Well, I suppose in an ideal scenario, you just stimulate that's more funding to research drugs, but I understand that there isn't always money for that.
Yeah.
So
I forget, I do want to let you finish, but to that point, there was another reading, I forget if it was this one or not, that said just throwing money and giving infinite budgets isn't always the solution, because in that case, because you can, it sort of takes away the element of good planning and strategic planning.
And of innovation organization. If you don't have the innovation organization that's going to enable you to avoid big gaps in the system, you're just not going to get there. So throwing money at a problem without tackling the innovation organization problems is problematic.
Yeah. So ideally, yes, money and money would.
Yeah, assuming that you can use the money properly.
Yeah.
One thing that I was curious about, I was confused how antibiotics can simultaneously be working too well, and you can have tons of antibiotic-resistant bacteria, which implies that antibiotics are not working too well. So if someone could clarify that, I would appreciate that.
That's yours, Chris.
Yeah.
So I think the problem is that, say Pfizer's drug is doing really well, so like they give these antibiotics to their patients, and these patients are getting cured, and so that means like if they're getting cured and they're not really getting these diseases, that means that drug's not going to be really used as much. And then at the same time, because these patients have used the drug, there is like, you know, antibiotic resistance growing. And just because it's been around for so long, it's inevitable that resistance is going to build up to the point that the drug is no longer effective, right? Because it's like been out for 10, 15 years.
But that
so it's not going to.
But that resistance can only develop if lots of people are using the drug.
I mean, obviously a lot of
successful.
people have used it, and it is obviously like critical mass have used it. It's been successful, but like it's become, you know, it's a really effective drug. So maybe there's not like repeat people in the way that other drugs might have a lot of repeat users. Maybe it's treating a large population, but like people don't really get the same kind of strain of disease multiple times, something like that. I imagine.
Chris, part of the problem is that we overprescribe antibiotics to an absurd extent, and we're sticking antibiotics in everything like hand soap, and we're just virtually guaranteeing our own kind of Darwinian dilemma.
Yeah.
It seems to be like applying the language of this class in previous lectures. We're playing catch up with an innovation problem instead of purely innovating, which doesn't seem like a very American way to tackle this problem. It's kind of odd because it's almost like we're being outplayed by nature, which, I mean, most of our big successes over the last 200 or 300 years have been us figuring out how to manipulate nature to our advantage. So it's kind of an interesting point from.
I left my American flag at home.
If that's all we have for that, I do have one more question for the FDA reading. More on the standard setting side of things. What do you guys think, again, are the roles and responsibilities of such an agency that sets these standards to encourage people to take risks and bring maybe slightly riskier drugs to market? Because the reading mentioned that a lot of researchers won't even go down that path because they know how arduous and tough to traverse it is. So is there something the FDA could do to?
Okay, I like what Bill said in terms of like, okay, it's a very hard process, but once you do it, you're kind of set. The only thing I would question is like I would tier it, because there's probably different kinds of drugs that have different specialties, and they're probably something that, you know, there's probably drugs that I really want to get tested really, really, really well, but there's some that even if I do test them, I still don't know. And some drugs that can probably get passed like faster. So I would figure out like how does the scheme work. Look at the data in terms of like how are these drugs being passed, how long does it take, which ones were relatively quick, see if I could like restructure the organization so that I can optimize for, you know, the stuff that really matters, and like the stuff that doesn't really matter as much, like it's not a focus. So instead of having a linear kind of everything is the same.
So are you saying maybe make a function, make the funding or whatever a function of, say, quality and the amount of time it would take to get passed? So then, like, if you need a drug that maybe would only work for a few people, you can make it so it would be really high quality, whereas if you have a drug that needs to work for a lot of people but you need really quickly, then you can make it so that it, I don't know, it works for, it's less robust, works for fewer strains, etc. Are you saying something like that?
Yeah, something like that. In terms of like, so say, because you're also thinking about like compound interest.
Yeah.
So say I know that if I make this drug, I'm going to save the government, you know, like $50 million a year, $80 million a year, like over like 4 or 5 years. So if it's something that's going to make a big impact, how about we go faster, we can iterate faster. So we'll have priorities for drugs that really, really matter. I don't like the argument of saying, oh, not a lot of people are going to use it, so we're not going to prioritize it and let's put it in the back, because that's kind of false. Or maybe you should create another organization that only focuses on those kinds of drugs and split up the FDA into one that focuses on that, so it gets equal review. But that's kind of the same way of working.
So just to kind of summarize here from you're all good presentations and good questions. FDA is sitting on a really critical part of the problem. So if we could significantly speed the drug approval process, and if we could significantly lower its cost, we solve a lot of problems here, right? We can be much less reliant on a blockbuster drug model. So it seems to me that in terms of the panoply of fixes to this gap in the innovation system, really paying attention to how to accelerate, Martine, as you were pointing out, the review process at FDA, and you know, it's very hard to reduced safety requirements. It's just not going to be acceptable to the public. But if there are new ways of using big data and analytics and simulation and modeling, those potentially present very significant improvements to this process here that could really help tackle this problem. So putting some money on that one, I think, could be really key. Now, the issue, then we go back to NIH. NIH is not organized around those kinds of technology problems. So how are we going to do this, right? So we have another dilemma as soon as we arrive at the answer. Anything else?
Oh, I mean, I guess as we transition into Bill's reading about this being a legacy sector or exhibiting a lot of legacy features, I'm curious about what you, Bill, or the class thought about the political viability of it. I guess in terms of Martine's sort of proposal toward a tiered approach, if we thought it was more politically viable to do this for either therapeutic drugs or for sort of cure-all interventions, there seems, in my very limited study of the life sciences, to be a proclivity towards the therapeutic drugs and interventions because they're more sustainable and profitable. So do we think that that could be a potential market opportunity to test a DARPA-like system or to test a sort of improved speed of acceptance of the drug?
Let me throw that back to the group here.
I know. I like the point, I forget when we mentioned it, about how drugs work too well. So they want to have recurring revenue, but I think as the government, you get you have to pay that. So like, it'd be interesting if the government's like, okay, well, we know over the lifetime, if we don't solve this now, it's gonna cost us like $1 million for this person. So, you solve it today, we're gonna give you 20K, right? Which is way cheaper for us overall in the long term, but you're not getting paid $10 per drug or $100 per drug. And so it's like a kind of a win-win, because it's really good revenue for the company and it justifies having a super drug that really, really works. And it gives them enough money in their balance sheet. I don't know if you guys know how Warren Buffett got rich, but he got an insurance company and they give him a lot of cash that they can invest in other companies. And it's really good for companies having a lot of cash on hand. So.
Who'd have thought?
Well, no, it's just like a lot of them don't have a lot of cash on hand at any given time. So it's like they have their assets distributed between physical, and so like it's really good to like be able to move quickly and buy all this stuff. And it's just not a thing that happens that easily. There's also a lot of tax benefits. So that's why people do it.